Okay, this section of Unit 4, Trigonometric Functions, is about inverse trigonometric functions. This is a more abstract concept, and some students struggle with this. I will explain this here, and then I'll also explain it during the live lessons. So, just to review, here is your sine function. The sine function goes from negative infinity to infinity on the domain, and the range is -1 to 1, including the -1 and the 1. If I want to evaluate f of pi over 2, what that means is sine of pi over 2 is equal to 1. And I could look at the graph. There's pi over 2 right there, and the y value is 1. If I want to evaluate f of pi, so then the sine of pi, here's pi right here, is equal to 0. The y value is 0. And I could do this for many points, infinitely many points. That's why the domain is all real numbers. But there's sometimes when we're looking at inverse functions. We looked at inverse functions for exponentials, which are logarithms. We looked at inverse functions for quadratics, which are radicals, for cubics, which are cube roots. And so if you know something about a function, then you know something about its inverse function. You've all heard of a vertical line test. Well, for inverse functions, we have a horizontal line test. And what happens here on a horizontal line, if I were to run a horizontal line through here, what happens is it crosses this function in more than one place. So that means that function cannot have an inverse function unless I make some changes. So the changes that are made is I just want to look at a portion of this graph. And the portion that we all look at everywhere, mathematicians do the same thing throughout the whole world, is this section from here to here. I'm just going to look at this portion of it. Because then what happens, I can run a horizontal line through here, and it's only going to be that part of it. So that is what I've graphed here below. The inverse sine function switches the x and the y. So this section right here becomes this section right here. Up here, I'm looking at the values from negative pi over 2 to pi over 2. But I'm switching x and y, so that becomes my range. My domain goes from -1 to 1. And so if I want to evaluate now, I have specific values, f of 1. Well, f of 1, here's 1 here. Come up here, I get pi over 2. F of 0 is 0. There's no other values. If I went up here, I could get multiple values for 0. I could say, well, sine of 2 pi equals 0. I get sine of 3 pi equals 0. So there's multiple answers. Down here, there will not be. Same thing happens with cosine and tangent. So here's your cosine function. Domain is all real numbers. Range goes from -1 to 1. Cosine of pi over 2 is 0. So cosine of pi over 2 is 0. Cosine of 2 pi is 1. But in looking at this cosine function, it does not pass the horizontal test, or horizontal line test. So I have to decide which part of the graph I'm going to look at. Universally, everywhere, we look at the values from 0 to pi. This is the portion here that's graphed here. And I see a mistake here. It doesn't go from negative pi over 2 to... The range goes from 0 to 1. I'll correct that before I make copies. But my domain goes from -1 to 1. my range goes from 0 to pi. If I wanted to evaluate f of 0 equals pi over 2, f of 1 equals 0. So there's only one answer, and it's a very specific answer. So this graph is this portion of the cosine graph that looks like that. Tangent function, here's the tangent function. There's all these different parts, and these keep going forever. So the range is from negative infinity to infinity. And the domain is all real numbers except the multiples of pi over 2. That's where these vertical asymptotes would be. So I could draw all the vertical asymptotes here. And I could put arrows on every single one of these ends, because it keeps going. So when we're looking at the inverse tangent function, the section that we're looking at is this section here. So that's what's graphed here, and it keeps going. There's going to be horizontal asymptotes here. The horizontal asymptotes run horizontally along the pi over 2. So that's why the domain is from negative infinity to infinity, because it keeps going left and right. The range, it does not include that ends at negative pi over 2 and pi over 2 because of the asymptote. So I don't use brackets, I use parentheses. If I wanted to evaluate f of 1 is here. I get pi over 4. F of 0 is 0. So there are specific answers to these.